Hey, so I'm just getting finished up with a radon mitigation system installation. We've got a house in Sequoia Hills, kind of an older house, I think 1950s construction. We've got a partial crawl space. Now this is actually conditioned, doesn't have any outside air. It's closed off, it's part of the conditioned space. But we have this crawl space, and then we have a finished side of the basement. We've got a concrete slab that we had to treat. We had to get suction underneath the slab. And then we had to create a vapor barrier or sub-membrane depressurization. So we installed the vapor barrier and created suction underneath. So let me walk you through this system and show you what all we've got. I am just getting finished up sealing up some tape along the top of the wall. We had a couple of pieces that came loose, so I came back to make sure those get sealed up correctly. But this crawl space had black loose lay vapor barrier over the top of it. So we installed 10 mil plastic. All of our seams are overlapped and taped, and then we have suction coming underneath this. I'll show you that in a second, but the tops of all of the columns are sealed, the tops of the walls are sealed, any pipe penetrations, we've sealed all of that up. The idea is we're creating suction under this membrane, and so we need to seal all of the joints. We want the air being pulled from below the membrane, not from above it. We don't want this conditioned air because, again, this is part of conditioned space. So we want only the air from below the membrane, the vapor barrier. We want only that air being drawn out, nothing from in here. We want to be mindful of the energy efficiency of the house. Now, this is where we have our suction point. So this is the sub-slab suction. We drilled a 5-inch hole in the slab. There was a little bit of gravel base. It wasn't as thick as we like to see. On an older house, you always have to worry about how thick the gravel is going to be. We had about 1 inch to 2 inches of gravel, not a whole lot, and then a lot of red clay. But what we did is we actually got pretty close to the cast iron waste pipe. So when we dug around our suction pit, we were able to get in contact with that waste pipe, with the idea that if we can we basically would follow the path of that waste piping and hope that the dirt around the pipe is loose, so we can pull air basically from the finished space. On the other side of this wall is a bedroom, and then we have a den area. So we're trying to create suction in these areas all from this singular point. So if we can take that pipe and the loose dirt that we hope is around it, which it runs that direction to a bathroom, if we can create our suction around that loose dirt, then we just extended our pressure field. We created better suction through the conditioned side or the finished side of the basement, and creating better pressure field extension below our slab. So that was the goal there. So we come up and then we tee off. We teed this direction to go to our sub-membrane depressurization, and then we come this direction to go out to our suction pipe on the outside. So we have two different suction points. We're sucking from below the slab, and we're sucking from below the membrane. Come outside. There's our fan system. Now this is a greenhouse space. This is not part of the conditioned space. This is not insulated, it's not air sealed. This communicates with the outside. It's covered, so it has weather protection, but it's not air sealed. Air is going to move in and out of this area. So this fan is allowed to be out here. What we did is we took our fan system, we routed the piping over, and then we go out through this paneled roof, which here we transition to downspout material, and then we take it to the roof. We have one extra fitting that goes on top of that. We want to be about 12 inches above the roof line, so we have one extra fitting we're going to put up. We still have a couple of things that we're working on here. This isn't completely finished. One of those being the extension on top of the downspout, the other being electrical power. Right now we're running our power off of an extension cord. We're going to mount a receptacle near the fan on that side. That way the power switch, the power disconnect, is going to be mounted here. But this is a RP265. We've got high suction. We use this high suction fan because we were worried about not having enough gravel underneath. Sure enough, when we drilled our hole and we got down, we do have communication under the slab, but it's not like we would like to see it. If it's a good gravel base, we probably could have got away with a different fan model, but the 265 was going to work good here. Another thing that we could have used and we haven't because it seems to be working. I'm going to show you our test results in a second. This is a damper. This damper, I had an idea that we could actually dampen off the tea that comes over to the membrane. We could install this damper in that piping with the idea that we want more suction to be coming from the slab. That's where there's going to be more restriction, there's going to be more resistance. So we want the fan to try to pull from the slab more than the membrane. It's pretty easy to pull air from below the membrane. This is all loose. It's below the slab where we're going to have the challenge. Now I've went ahead and tested. I want to show you these two test locations. I have a monitor over there. I had it up on a tripod. I've already taken it down, but I have that monitor there, and then I've got another monitor in the basement. I don't want to go into the living space. I'm not. I don't want to take you into somebody else's home right now. I'm going to show you all of that. But there's another monitor inside. When we installed this system and got everything up and running, we went ahead and tested. We've had these boxes running. It's actually 7 days exactly today. And I put one in this area, and then I put one in that area because I wanted to test the idea of our membrane and how good we're creating suction here versus how good are we mitigating radon in the conditioned space depending on the suction below the slab. So if it wasn't, if our numbers weren't where we want them below the slab, I was going to install a damper system, restrict airflow in this side, at least dampen it down, and let more air be pulled from the vertical pipe coming from the slab. Now the good part about it though is that both of these test monitors, they've ran for 7 days, and the overall average is 2.1 picocuries per liter. So it's actually worked on both sides. The levels are exactly the same. It seems like everything is working good. We'll continue to do some follow-up testing just to make sure everything's working. Ultimately, if we need to put in this damper system, these are pretty cool because you can adjust these dampers to pull. You can adjust them to open and close as much as you want. So if I want full force, then I can open the damper all the way up and we get full force. Versus if I want only a portion, like if I installed it over here, I would probably close it down to about that much. About 3/4 of it would be closed off. So we're going to restrict the suction that comes from this side because we want more air to be pulled from the slab. So that's the cool thing about these dampers is you can adjust the system to make it do exactly, you can manipulate it to make it do exactly what you're looking for, creating the suction where you want it and restricting the suction where you think that it's probably okay. So I don't have to put that damper in on this one, at least at this point. We could come back and retest, and if something changes and if conditions change, we can always tap into that pipe and do that. But as of now, everything's working good. We have 2.1 on a 7-day test. We have 2.1 overall average, so far so good. But I wanted to take you through this system, a little bit more of a complex system, a lot of different variables to look at, but fortunately this one has worked out really well. So proud of the work here.